Hey math kids, today we're going to talk about definite integrals, and this is what a definite integral looks like. Remember, it's just area under a curve, and then we'd look between 1 and 2, and we'd find the area under that curve. Okay, so to do that, we take the antiderivative, so we raise the exponent by 1, divide by the new exponent, raise the exponent by 1, divide by the new exponent, and then raise the exponent by 1, divide by 1. Okay. Then we're going to evaluate this from 1 to 2. And so I'm going to replace this negative 4 over 2 with just a negative 2 because those would cancel. And what I'm going to do is plug in a 2 for all the x's first. So we get 2 to the 4th over 4 minus 2 times 2 squared plus 5 times 2. Now we take all that stuff and we subtract it from what we get when we plug in a 1 for all the x's. Okay. Now we just need to evaluate all this. So this is 32 divided by 4 gives us an 8. And then 2 squared is 4. That we get a negative 8 plus 10. And, oh, no, this is 16. That's where I went wrong. 16 divided by 4 is 4. 4 minus 8 would be negative 4. So we have negative 4 plus 10. And then we combine those. And so this entire thing was reduced down to 6. Okay? So I'm going to write this 6 minus, and then depending on what we get here. So 1 to the 4th is just 1. So we get 1/4. 2 times 2, or 2 squared, 1 squared is 1 times negative 2 is negative 2. And then 5 times 1 is 5. Okay? Combining those, we get a 3. So we have 1/4 plus 3. And so if I do a 4 on the top and the bottom, we get 1 plus 12 over 4. So minus 13/4 is what we get over there. And so if we multiply the top by 4, bottom by 4, we get 24 minus 13 over 4. And so if we subtract that, we're going to get 1 and 1. So we get 11/4. So the area under this curve in between 1 to 2 is 11/4 units. Okay, moving on, we go from 1 to 4. We get 2 square root of x plus 3 over x dx. Okay. So I'm going to rewrite this as 2x to the 1/2 and 3x to the negative 1. Okay, when we take the antiderivative, we raise that by 1, and then we multiply by the reciprocal. Okay, we raise it by 1, so if it's like this, sorry, this is a special case. It's going to be 3 natural log absolute value of x. Okay, now we evaluate this entire thing from 1 to 4. I'm going to simplify this just a little bit, so we get 4/3 x to the 3/2 plus 3 natural log of the absolute value of x, evaluated from 1 to 4. Okay, if we plug in a 4 right here, we get 4/3 times 4 raised to the 3/2 plus 3 natural log of the absolute value of 4. We take all of that and we subtract what we get when we plug in a 1. 4/3 times 1 to the 3/2 plus 3 natural log of the absolute value of 1. All right, now it just comes down to evaluating that. So if we do 4 raised to the 3 halves. That's like saying 4 cubed under a square root. So that's 4 and 4 and 4. This pair comes out, and that becomes a 2 and a 2, and that comes out. So this entire thing is really just 4 times 2, or 8. So we get 4/3 times 8 plus 3 natural log of 4, because the absolute value of 4 is just 4. Okay, if we do 8 times 4, we get 32. So we get 32/3 plus 3 natural log 4. All right, so that's that first pair of brackets. We get a minus sign. Okay, 1 raised to anything is going to give us 1, so this is just 4/3. And then this is natural log of the absolute value of 1 is the same as natural log of 1. Natural log of 1 is just 0, and 0 times 3 is 0. So this entire bracket just becomes 4/3. Okay, so now we're just going to do 32 minus 4. That's going to give us 28/3 plus 3 natural log 4. Okay, your book takes it one step further for some reason. Not sure why they do it, but I'll just show you what they did. They think of this like 2 squared, and then they bring the 2 out in front and multiply it by the 3. So it's 6 natural log 2, and 28/3 is added to that. Okay, I'd probably leave it as that blue answer right there, but if you want to see exactly what the book got and how they got it, that's what they did. Okay, now we got another one. This time we're going from 0 to pi/3, and sine of 2x. Okay. Now, if we take the antiderivative of sine, we get negative cosine. And then remember, with the chain rule, we have to divide by the derivative of the inside. So we divide by 2. We evaluate that from pi/3 to 0. All right, so we plug in the top value. So we get negative cosine of 2 pi/3 over 2. And that entire thing is subtracted negative cosine of 2 times 0 over 2. Okay, so if we look at our cosine graph, this is really just cosine of 0. Cosine of 0 is just 1. And so this is like negative 1/2 in this bracket. Okay, then we have our subtraction sign right here. And we're going to have another bracket with this value. Now cosine of 2 pi/3. So if we're using our unit circle, this would estimate to about 2, so we know it's going to be in the second quadrant. This is where I'm estimating that as 1.5, and this as 3. Goes somewhere in there. So I'm going to subtract out my pi halves right there. So I get 2 pi/3 minus pi halves. So this is going to be 2 over 2. This is going to be 3 over 3. So we get 4 pi minus 3 pi over 6. So that's pi/6. So it's our first rotation. And if we do our tick marks, we know that, let's see, this one is square root of 3, like that. So this one is 1/2 square root of 3 halves. And that's where we're symmetric. And so we get negative 1/2 square root of 3 halves. And since it's cosine, it's our x value. And so negative 1/2 corresponds to just that. So we get negative 1/2 over 2. All right. There's a lot of negative signs going on here. And so so first off, the negative just cancels. And so now we have 1/2 divided by 2. So to see that a little bit better, 1/2 divided by 2, that's 1/2 times 1/2. And so that's really just going to give us 1/4 for that bracket. And then if we subtract a negative, we're going to be adding 1/2. And so you can either just, kind of know that that's 3/4, or we could multiply this by 2 over 2, and that's going to be 1 plus 1 plus 2 over 4, and that still gives us 3/4. So 3/4 is our final answer on that one. Okay. We still have a few more, or at least one more, let's see. Yeah, we have one more problem. Now, they want us to do this on a calculator. So what we're going to do, 2 to 5 x e to the x dx. I'm going to open up my calculator. Alright, so for mine, I go second, catalog, and then I need to go all the way down to f, because I'm looking for fn int. Okay, it's right there. Okay, so you go x, I'm just typing in the function, e to the x, so that's x times e to the x. Then you do comma, then you tell it what it's dependent on, which will almost always be x. And then you go lower to upper, I think. Maybe it was upper to lower. Yeah, so it is lower to upper. And it wants us to write it out to 4 significant figures, so it's 586.3. Okay, if you need additional help, come to Math Lab. Until then, calculator.